All right, let's take a look at question number 3. We're going to be doing exactly the same procedure for problems 1 and 2. We're going to express the given conic in standard form, identify it, find the properties, graph, label, state the definition of the conic, and the context of the problem. So what if we have the conic with the equation negative x squared plus 4y squared plus 4x plus 16y plus 8 equals 0. Now what kind of conic section is this? Now if you look at the squared variables, you notice that we have two squared variables. So that means it's either a circle, an ellipse, or a hyperbola. Now, since the signs, you have a negative, one of the squares is negative, that automatically makes it a hyperbola, all right? So this is the general form of a hyperbola, general form. Our first task is to convert this into standard form, okay? So let's collect variables together. Now you notice that the x variable is squared, the leading term in the x world is squared, so I'm going to move it back and put the y in front since it's positive. So I have 4y squared plus 16y minus x squared plus 4x. Okay, I have the y's together, and then the x's together, and then I'm going to subtract 8, move it to the other side because it belongs to neither the x nor the y world, so minus 8. Alright, now what we're going to do is divide our worlds into two. We have the x and the y worlds. And then we're going to create two perfect square trinomials by completing the square. In order to complete the square in these two expressions in the two worlds, we have to make sure that the squared term has a coefficient of 1. So we notice that this has a coefficient of 4, so that needs to be factored out. So we're going to factor out the 4. And that leaves us with y squared plus, factoring out 4 from 16y, you have 4y, plus the term that completes the square in the y world, okay? Now let's shift our attention to the x world. We have a minus 1 here, so we have to take care of that negativity. So we'll pull out a minus, so we have negative. You could put a 1 out there if you want, but we don't have to. Negative, parenthesis, x squared. And if you factor out a minus from a plus, this becomes a minus 4x, plus the term that completes the square in our x world, making it into a perfect square trinomial, okay? All right, negative 8, we're going to add terms here to make sure this is a balanced equation. So before we do that, let's figure out what the terms that makes these two quantities perfect square trinomials. So starting with the x world, b of x is 4. So we're going to divide that by 2, which is 2. And then we square that, that's 4. So we're going to add 4 here to make this a perfect square trinomial. And in the x world, b of, oh snap, this is b of y, both is b of x. This is b of y. Now what we're going to do is b of x. Okay, so this is b of y. Now b of x. B of x is negative 4. Divide that by 2, you get negative 2. And when you square that, you have 4. So 4 being added here makes this a perfect square trinomial. So what do we add on the right side of this equation? In order for it to be a balanced equation, we're going to add 4 times this term that we introduced right here, 4 times 4. Now, how did that happen? We added a 4 in this parenthesis, but there was a 4 out here that's been multiplied by the 4 that we introduced. So in essence, we added 16 here. So that's why we have a 4. This 4 is for the 4 out here, the coefficient. And this other 4 is the 4 that we added by completing the square. In the y world, we have a, imagine there's a negative 1 here, so it's going to be a minus. This term right here, 4, is the only thing that we introduced there, minus 4. Okay? All right. Now, let's go ahead and finish this off. So you might wonder, why is this a negative if you multiply plus or minus? That's why we have a minus there, okay? Now we're going to factor this perfect square trinomial by using the factoring trick. You root the first term and the last term, and then you bring down the middle sign, okay? So let's see what that gives us. Just do a 4 on the outside. 4 times y plus 2 quantity square for the y world, all right? And then we have minus, you root the x square and root the 4 and bring down the middle sign, and then we're going to have x minus 2 quantity square. Now on the right side of the equation, let's go ahead and simplify this. This is negative 8 plus 16 minus 4. That gives us positive 4. Now to get this into standard form, we just have to set it equal to 1. So what we're going to do is divide every single term by 4. Divide this by 4, divide this by 4, and divide that by 4. Alright, so if we reduce that, we're going to get y plus 2 squared over 1 minus x minus 2 squared over 4 equals 1. Okay, so there goes our standard form of the equation of the hyperbola. So let's write it down, standard form. Now, what we're going to do is find the properties. Okay, so let's go ahead and do that. Properties. Okay, we're going to start by identifying what the conic is. We already did that before. What kind of conic is this? This is a hyperbola, because we have two squares, a minus, and the coefficients were different, or the denominators are different, okay? Next thing we need to find out is the center, HK. Opposite of the number next to the x is positive 2, and then opposite of the number next to the y, negative 2. Now you have to be careful. You have to pay close attention to the variables, all right? X's do not always come first when you're orienting conic sections in standard form. So you have to be careful with that. Now we have the center. Next thing we need is the direction of the central box. Okay, let's write that down. direction of central box of central box. Okay, so underneath the y squared quantity we have 1, so we're going to do the square root of 1, which is 1. So we're going to go up and down 1 unit, and then square root of 4, which is 2, is underneath the x, so the central box goes side to side. Now, which of this is the real and which is the imaginary axis? When you're dealing with hyperbolas, the sign is what counts. Whichever one is positive, that's where the transverse or real axis is. Okay? And then the one that has a negative in front, that's the imaginary or conjugate axis. So let's go ahead and label it. The one that's positive is the y. So this is going up and down, the direction that goes up and down, that's your transverse or real axis. Okay, real axis. All right, and then the one going side to side, that's your conjugate or imaginary axis. Okay, now next thing we need to find is the C of the foci. C of the foci, we have two focus here. C of the foci, we're going to do the square root of, since we have a minus here, we're going to add the denominators, 4 plus 1, which is equal to 5. So we have the square root of 5, which is approximately 2.24. Okay, so it's approximately 2.24. Now, what direction is it going to go? Is it going to go side to side or up and down? Well, it goes in the direction of the transverse or real axis, okay? So it's going to be going up and down from the center. All right, next thing we need to find is the eccentricity. of our hyperbola, eccentricity. So our eccentricity is basically the C of the foci divided by your real axis, okay? So C of the foci is square root of 5, that divided by the real axis, which is 1. So our final answer is basically square root of 5. Square root of 5 or 2.24. So there goes our eccentricity. All right, now let's go ahead and take a look at the graph. Let's go ahead and graph the hyperbola. All right, so the center is 2, -2, so that's located in quadrant number 4. So we have to make our fourth quadrant sufficiently large to compensate for that shift, okay? So shift your x-axis to the left, your y-axis to the left, and shift your x-axis upwards somewhat. So there you go. Now let's graph the center. Center is 2, -2. So this is our x-axis. So y-axis. So 2 and -2 is down here. Next thing we're going to graph is the direction of our central box. We're going to go up and down 1 unit. And then we're going to go side to side, I think 2 units. So there goes your central box. Now let's go ahead. So 1, 2. All right, so there goes your central box. Now let's go ahead and graph the central box. We're going to use dotted lines here. Let's make this dotted. Okay, perfect. All right, so there goes your central box. This is not part of the graph, so just make it dotted right now. Dotted, 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 like that. Okay. All right, now we have our central box. Next thing we're going to graph are our asymptotes. So to graph your asymptotes, you just basically connect the vertices of your central box like that. I'm going to extend it in a second. All right, so when you're sketching your hyperbolic curves, you want to ensure that you approach the asymptotes, okay? And you never want to go into that central box, that restricted area. You have to reside outside it. Have these hyperbolas guide your construction. So what was the orientation? What is the, oh, we also have to indicate the opening of our hyperbola. Let's go ahead and indicate what that is. What is the opening? In what direction does a hyperbola open? It opens in the direction of the transverse or real axis. In this case, it's up and down. So opening is up and down. So we're going to have a hyperbola opening upwards and downwards right there. Okay? So let's go ahead and draw our graph. So from here, to draw it as best as you can, you approach the asymptote. It just goes on like that forever. Okay? And from here, you approach the asymptote like that. And then you can do this side to the best of your ability. All right, so there you have it, your two your hyperbolic curves. Okay, now what we're going to do is we're going to proceed to start with to start labeling our hyperbolic curve. Okay, so the first thing we're going to do, I like to start by graphing my my transverse axis, transverse or real axis. This is a transverse or real axis right there. So we're going to graph the center first. So where's the center located? Let's go ahead and label that. So this right here, that's the center. The center has coordinates, center's coordinates 2, -2, 2, -2. And then this is our transverse or real vertex 1. So, well, actually, just the only vertex that we have. So this is vertex 1. Vertex 1. Vertex 1 is going to be 1 unit up. So we are adding 1 to our y-axis. So it's going to be 2, -1. And then this is vertex 2 right here. Now, vertex 2. And that's going to be 2. And then you subtract 1 from the y coordinate 2 comma negative 3. Next thing we're going to graph are our foci. So our foci is 2.24 units up and down. So 2.24 is going to be somewhere here. That's our first focus. Let's go ahead and label that. This is going to be, put it right here. Focus 1, focus 1. Focus 1 is our x coordinate is still 2, and our y coordinate is, you went up 1, 2, and then 0.24, so 0.24. That was our focus 1. Focus 2, we're going to go 2.24 units down from the center, 1, 2.24. So right there, it's an approximation. There goes our focus 2. Focus 2, let's bring this up a little bit. Focus 2, coordinates of our focus 2 involves subtracting 2 from the y coordinate of our center. So the center is 2, so we subtract 2, you have negative 4.24. Okay, so 1, 2, 3, 4.24. That goes focus 2. All right, next thing we're going to label is the length of our transverse axis. So let's go ahead and label that. We'll put that to the left. So put that transverse axis length. How long is it? You're going up and down 1 unit, so it's total length of 2. Now let's draw our transverse axis line. So our transverse axis line is going to be the line that contains our focus, our foci, center, and vertices. So that line right there, that's our transverse axis line. Let's change the color. So what's the equation of our transverse axis line? Let's go ahead and label what the equation is. So transverse axis line, transverse axis line, it's going to be x equals the x coordinate of the center, which is 2. X equals 2. All right, now let's go ahead and draw the conjugate or imaginary axis. So this right here is your conjugate or imaginary axis. All right, so let's go ahead and label it. So this is our, put it up here, conjugate axis. You can also call it imaginary. Now, what's our conjugate or imaginary axis line? The conjugate or imaginary axis line is going to be this horizontal line right here. All right, I just changed the color of our conjugate axis line to red, so let's go ahead and label that. So this is going to be our conjugate axis line. Put a label, so this right here, our conjugate axis line, conjugate axis line is going to have the equation y equals the y coordinate of our center, which is negative 2. Okay? All right. So the length of our conjugate axis is 2 units in both directions, so the total length is going to be 4. So conjugate axis length is 4 units long. Okay, so that's that. Now let's go ahead and write down the equation of our asymptotes. For that, we're going to be using the point slope form of the equation of a line, y minus y1 equals mx minus x1. All right, what you want to notice here, or note here, is that our x1, y1 is the center. So our center is x1, y1. All right, our x1, y1 is 2, comma, negative 2. All right, and our m is basically the rise over run using the direction of our central block. So rise 1, run 2. So it's going to be plus or minus 1 over 2. So when we put everything together, that basically gives us the equation of our asymptotes. Okay? So the one that's going up, that's the one with a positive slope. So let's go ahead and write down that equation. So it's going to be, this one is going to be, this is asymptote 1, asymptote 1. That's going to be y minus y1. y1 is negative 2, so minus minus makes it a plus, plus 2 equals m, positive slope, 1/2 x minus x1, x minus 2. Okay, so that's the equation of asymptote 1. Asymptote 2, it just has the opposite slope of this, so asymptote 2 is up here. Label that. This is asymptote 2. Asymptote 2. So using the same procedure, we have y minus y1, y plus 2, the same thing as this slope, as this equation, but just take the opposite of the slope, so negative 1/2 times x minus 2. All right, so there goes the equation of your asymptotes. Okay, let me just partition this a little bit so you don't get confused. All right, so there you have it. Now let's go ahead and write down the meaning of our result, the definition of our of a hyperbola in the context of this problem. Okay, so to do that, let's go ahead and write that down. The definition is as follows. The locus of points, whose difference of distance from two fixed points. From two fixed points, these fixed points are the foci. Okay, from two fixed points, what are our foci again? 2, points 2, 4, and 2, negative 4.24. It's constantly the length of the transverse axis. Okay, it's constantly 2 is the hyperbola with the equation, and they write down the original equation, negative x squared plus 4y squared plus 4x plus 16y plus 8 equals 0. All right, so that's that.